Hi guys, hopefully you took your notes home. We're going to have some lecture and conversation about section 15.2. So something you can tell about something without changing its identity. So for example, I look at my pen, I can see that it is gray. I can tap it and tell that it is hard. I don't have to do anything to the pen to tell these things about it. And so we call anything that you can observe without changing something's identity, we call a physical property. Oops. So some other examples, I guess I will use color, shape, volume, which remember is how much space it takes up, so we could use water displacement to figure out something's volume, but that doesn't really change it, right? We could find its density. We could take its mass divided by its volume and find its density. I could take something that is solid and melt it and figure out what temperature that happens at. That's called the melting point. But again, that doesn't change what it is, right? So if I take solid ice, it's water, and melt it, I can see what temperature that happens at. It looks different, but it's still water. Okay, so melting point and boiling point are the ones people usually misidentify because they think, oh, it's changing, it looks different. But remember, it's still the same thing. You can melt something, freeze something, evaporate something, and it will look different. But again, it's maintaining its same identity. So we can use some physical properties to separate out a mixture. So if we have things in a mixture, remember, they're not chemically bound together, they just kind of happen to be beside each other. And a couple physical properties are very useful for separating those. One of them is magnetism. And this is only useful for a few substances that happen to be magnetic. So if you have a mixture of like iron, which is magnetic, and sand, if you pass a magnet through that mixture, the iron particles are going to attract to the magnet. You pull the magnet out, and you would pull the iron out too, leaving the sand behind. Another physical property, is just size. Okay, so imagine I'm making macaroni and cheese, and I'm at the step where I have a mixture of cooked pasta and water. So how am I going to separate the mixture so that I have the pasta separated from the water? Well, I'm going to use a filter. Okay, and so the filter has holes in it that are a certain size that let the water molecules through, no problem, and the pasta noodles have to stay behind. And so depending on what you're trying to separate, you're going to choose a different filter. Okay, so another example you're probably familiar with is if I want to make some coffee, right? So I'm going to put my coffee grounds in my coffee filter, and the holes in a coffee filter are a lot smaller than the holes of a filter I would use when I'm separating my pasta out. Because if I used a colander or a pasta kitchen kind of filter to separate out the coffee grains would go right through, right? So you have to pick your filter so that the holes are small enough that it is causing some separation. So part of your mixture can go through the holes, or the pores we usually call them, and some can't. Okay, so those are all physical properties, things we can see, observe, measure without changing the identity of the substance. But when we were talking about a chemical property, oh, that's all messed up. Sorry, guys. This is a physical change. Okay. So this is a change to a substance that, again, does not affect its chemical identity. So you can think of these are just observations, things that we can observe about it, and these are things that we actually do, that we do change about it. So if I take something and bend it, that's a change, it's changed, but I have not changed what it is. Okay, it is still the same thing. Same idea if I tear something. So if I have a piece of paper and tear it apart, obviously it has been changed, but it is still paper. Okay, or evaporate. If I have liquid water and evaporates, it is changed, but it is still the same thing. And so these are kind of action words. But again, action words that do not change the identity of what it is you are talking about. All right, so we can also use some of these physical changes to separate out a mixture. This is one of those days I'm really sad that we don't get to be at school, because I've always kind of set one of these up and it's always kind of fun to watch, but this is where we are. So we have one really cool process called distillation, which if you've heard of, it's probably been in reference to some sort of alcohol. And yes, it is used in the production of various spirits and things, but it's also used to make things that you use every day, like gasoline and natural gas and diesel fuel from crude oil. So the idea is different substances in a mixture have a different boiling point, a different temperature at which they boil. So if we think about our picture down here, maybe this is seawater. So that's going to be a mixture of some solid particles, definitely some salt, and water. Okay, but the salt right now is dissolved in the water. So let's just pretend it's pure salt water so that we have a little bit of a simpler example. So if I was going to boil water versus boil salt, yes, I could heat up salt hot enough that it would melt and become a liquid, and then theoretically I could heat it up enough that it would become a gas, but it would have to be incredibly, incredibly hot. Okay, water is going to boil at 100 degrees Celsius, which we can achieve just by putting this above a flame. Okay, so we would have at first the temperature reach that the water would boil. Okay, so the water vapor is going to go up here, but the salt that's in the seawater doesn't boil at the same temperature, so it's going to stay behind in this round bottom flask. So up here the water vapor goes, and we're going to have cooled water kind of filling this outer tube. We have cold water, but again it's not mixing. You see it's separate from this path that our water vapor is going to take. So the water vapor is going to go up, and then it's going to be surrounded by cold. So it's going to condense back into a liquid because it is cooled down, and then out comes drip, 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 okay, pure water. Okay, so if we let this go all the way till all the water's gone, we'd have all the salt over here and just water coming out this side. And so the reason this works is because water and the salt have different boiling temperatures. Okay, so you're thinking what goes in our next blank here, we would say the vapors are then collected, separating it from the mixture. This is how crude oil is separated into all kinds of useful things like gasoline, diesel fuel, kerosene, which used to be used a lot more, but it's used in like some kinds of lamps. You put an oil in there that burns, and that's usually kerosene, jet fuel, all kinds of things. And so all of those things are already in crude oil. Okay, but they're different sizes. They have different boiling points. So as crude oil is heated up, we can separate the crude oil into these different things and use them for different purposes. On to page 79. Okay, so those are all physical. So those are all things we could do without changing the identity of the substance. So this is going to kind of be the opposite. We have chemical properties are things you can only tell about something by changing its identity. Okay, so these are what I like to call abilities. So just like with people, if you just look at a row of people, you can't tell just by looking who has what abilities. Okay, so I look at a row of people. Maybe one of them is a brilliant chess player. Maybe one of them is a great player of a trumpet. Maybe one of them is a math wizard. Okay, maybe one of them is a real wizard. I don't know. But you can't tell by looking, right? So to observe an ability, they have to actually do that thing. Okay, so some examples when we're talking about matter, a big one is flammability. I'm going to spell it wrong. Flammability, or the ability to burn. Okay, so I might have two clear, colorless liquids. Okay, so I have two beakers, and they both have a liquid in them that is clear and colorless, and they look identical. Okay, I can look at them, I can swirl them around. There's no way just by looking to know if they are flammable or not. Okay, so the only way to know is to actually do the action, to try to burn the thing. If it burns, then it becomes something different. Burning is a chemical reaction. Okay, so the example I have in my mind is if I had a beaker of water versus a beaker of rubbing alcohol, maybe. Okay, so if I try to burn the water, hopefully you know that's not going to work, but if I try to burn the rubbing alcohol, it will burn. Okay, so I can only observe that chemical property by actually doing it, by actually changing its identity into the products that we get when we burn that thing. Another one is the ability to rust. Okay, any kind of reactivity, but one of those that we can see really easily is the ability to rust. So I have two pieces of metal. Just looking at them, I can't know which one's going to rust if I leave it outside and which one won't, unless I either have a bunch of background knowledge or I do it. All right, so I leave these two chunks of metals outside. They get rained on. I give them a whole bunch of time. And then, and only then, when one starts to rust, I can tell if it has the ability to rust. Okay, so these are the abilities. And then the chemical changes are the result of a chemical property in action. So the flammability is an ability. When we actually burn something, it's a chemical change. Okay, so ability to rust is an ability. If something actually rusts, it's a chemical change. We have a synonym. These are also called chemical reactions. Those really mean the same thing. And we have some clues that if you observe one or more of these 5 things, it's very likely that you had a chemical reaction or a chemical change occur. Okay, so one is the production of an odor. Okay, so you buy milk, you leave it in the fridge, and some time goes by, and what do you do to check if your milk has spoiled or not? Well, you're going to smell it, because there's chemical reactions involved in milk spoiling, and those reactions produce an odor that's not great. But that's a clue that a chemical reaction has occurred. Also, we could have formation of bubbles. Okay, and I'm not talking about when we boil something. That's kind of a key idea here. So we're having some chemical reaction take place that produces bubbles. Okay, so examples. All right, so the classic, if I mix baking soda and vinegar together, it makes a bunch of bubbles. I didn't put the baking soda and vinegar on the stove and heat it up till it bubbled. It's from the reaction. Okay, or if any of you are bakers, if you add yeast to dough and give it time, it will produce bubbles. That's a chemical reaction taking place. Or really anytime you bake anything like a cake or bread that produces, those little air pockets, that's because it's a chemical change that's producing those bubbles. So we're producing some product of the reaction that is a gas, and the gas is the bubbles. Another clue is a color change. Again, not because you're heating it up. So like I could take an iron and stick it on a fire and it'll turn red, but then if I cool it back down, it goes right back again. So that's not the kind of color change we're talking about. I'm talking about, you leave your bread out and it gets moldy. Okay, so mold is growing. We have a color change. That's because there's all kinds of reactions happening in the process of mold being produced. Or if you think about, sorry, I wasn't really thinking about great examples. I guess if you, yeah, we're going to go on. Then we have release or absorption of heat. And I'm going to say, so this would cause something to feel hot or feel cold, and I'm going to say not because you heated it up. Not because you heated or cooled it. Okay, so this would be like if you are somebody who tends to get hurt or have chronic injuries, you may have experience with ice packs or heat packs that are reusable. Okay, so there's that little metal clicker in there that you click it back and forth, and all of a sudden that bag of gel gets hot or that bag of gel gets cold. Or if you have experience with going camping or skiing, maybe you've used those little hot hands packets. Okay, so those hot hands packets, they come in like a metallic kind of bag, and it doesn't get hot until you take it out of the bag. Okay, so what's happening there? So you take it out of the bag and it gets hot, especially if you shake it up. And what you're doing is as you shake it up out of that metallic bag is now air can get in and react chemically with the substances in the little hot hands packet. So you didn't heat it up. It's heating up because of a reaction. Okay, so that's kind of the distinction there, not because you heated or cooled it, but it gets hot or gets cold kind of all by itself. And the last one, we're going to have a new vocabulary word. Here's the formation of a precipitate. Okay, and when we use that word in physical science, or later on if you take chemistry, we're talking about a solid that forms from the reaction of two liquids. So like curdling of milk as it sours. The curdles are precipitates. Or we could say, this is when, again, I really wish we were going to have class, but there's lots of chemical reactions where we mix two things together that just look liquid, and then we mix them together and it looks cloudy, or we have tiny little particles fall to the bottom, and those would be called our precipitates. So, quick rehash here. So, properties are the abilities that they have. Okay, something can have an ability, but we can't necessarily see it until we try it. Okay, if we try it and it works, it's a chemical change or a chemical reaction. All right, so quick connection to earth science at the end of this chapter notes here. When we have rock that's breaking down, okay, so we have a big rock or an entire mountain made of rock, and we're going to break it down over time. That's called weathering. And weathering can be either physical. Okay, physical changes, remember, is just breaking it apart, but it would not change its identity. Or it can be chemical changes, where we're breaking it down in the process of doing chemical reactions. And reactions are always going to change the identity of our substance. So we have two types of weathering based on that. So we have what's called physical weathering. This would be from maybe waves hitting the shore. So the waves are coming in and they're hitting the rock over and over again and working slowly to break it down. Or this happens a lot. We can get water, liquid water, flowing into the cracks of a rock while it's liquid, and then it might freeze. And we know that water expands when it freezes. So as it freezes, it would expand and kind of force that crack in the rock to become bigger. And also we think of smashing of rocks by feet, hooves, tires, anything that is pressing on rock is going to work to crush it, but not change chemically what it's made of, what its composition is. And then, of course, we're going to have chemical weathering, which is going to be acid working chemically to change the exact identity of the rock. And there's other examples, but we could have acidic water. Plant roots also produce an acid. And there's a bunch more, but again, the key idea is we're going to take the rock and chemically change it while we're breaking it down. That's the end of our chapter 15 notes. See you later.